The next thing we're going to cover is general rules for graphing equations. I have three equations, and we're going to come up with the graphs for these three equations following some general rules. I know you've probably seen other ways to graph these functions, but if you don't have other ways to graph functions or equations, this method will always work. The first step you want to do is you want to solve your equation for one of the variables. Typically, if we have two variables, y and x, we typically solve for y. So I'm going to solve this equation for y. I'm going to subtract x squared from both sides, or add x squared to both sides. And then I'm going to divide both sides by 2. Once you have solved the equation for one of the variables, your next step is to substitute in values for the variable that you did not solve for. Since I solved for y, I'm going to substitute in values for x until I get sufficient number of points that I know what the graph looks like. So I have x's, I have y's. I'm going to substitute some easy numbers in. If I put a 0 in for x, 0 squared is 0. 0 divided by 2 is 0. If I put a 2 in for x, I get 2 squared is 4. 4 divided by 2 is 2. I'm going to put a 4 in for x. 4 squared is 16. 16 divided by 2 is 8. Okay, so that's going to give me the following 3 points on the graph. It's going to give me the point 0, 0. It's going to give me the point 2, 2. It's going to give me the point 4, 8. Okay, and that gives me this piece of information. But that's not the whole graph. I need to substitute some negative numbers into the graph. So I will substitute in negative 1. Negative 1 squared is a positive 1. Positive 1 times 1/2 is 1/2. So if I get negative 1, I get a positive 1/2. Let's put a negative 2 in. If I put a negative 2 in, I get negative 2 squared, which is 4. 4 divided by 2 is 2. So I have the point negative 2, 2. And I can continue substituting points in until I get what the curve looks like. You notice here I didn't substitute in 1. I picked a smart value because I knew I was going to have to end up with something divided by 2. So when I put the negative 1 in, I ended up with a fraction. And if you're uncomfortable with fractions and graphing fractions, you want to put in what we're going to call smart numbers. And we're going to see another example of using smart numbers with the next one. Again, the first step is to solve the equation for one of the variables. I'm going to again solve for y, so my first step would be to subtract 2x from both sides. And then divide both sides by 3, and I get y equals negative 2/3 x. Again, I'm going to want to make a table of values. So I have my x's and my y's. I solve for y, so I want to substitute in values for x. So I'm going to put a 0 into the function because 0 is a smart number. It's easy. If I put a 0 in for x, 0 times negative 2/3 is just 0. It gives me this point. And now instead of putting like a 1 or a 2 or a negative 1 or a negative 2 in the function, I'm going to put a 3 into the function so I can get rid of this fraction. If I put a 3 in for x, 3 divided by 3 is 1. 1 times negative 2 is negative 2. So when I put a 3 in, I get a negative 2. You should know that anything that has both or all variables to the first power is what we call a linear function, and we're going to go in more detail with that in one of the next videos. And that gives us the equation for a line. So for a line, I only need 2 points. So there's the 2 points, and I can just extend this on forever. If you have extra time, maybe put in a negative number. If I put a negative 3 in for x, negative 3 divided by 3 is negative 1. Negative 1 times negative 2 is positive 2. So in this case, if I put a negative 3 in, I get a positive 2 for my answer, and you should note that that point actually does lie on the line that I already drew. Last example is the square root of x. This one is already solved for y, so I want to put in the smart values for x so I can get the equation for the graph. So here's x and y. Well, I'm going to put a smart number in here, which is 0. The square root of 0 is 0. Put another number in, 1. The square root of 1 is 1. And if I need another number, I'm not going to put 2, because the square root of 2 is an irrational number. So I'm going to put a number that I could actually do the square root of, and that would be 4. And the square root of 4 is 2. It's going to give me 0, 0, 1, 1, and at 4, 2. And with my other graphs, I start putting negative numbers in here. And if you forget what the graph of the square root function looks like, let's try a negative number. So what is the square root of negative 1? We've learned that that is I, which is an imaginary number. And in the last lesson, when I talked about the Cartesian coordinate plane, I said we can't plot imaginary numbers on our regular Cartesian plane. So any negative value underneath this square root sign is not going to give me a point on the graph. So this is the entire graph of what is represented by the equation y equals the square root.